Okay, people, I've got to make an admission. This is hard for me to say this, but I'm an addict. I've been struggling with this for a while now. It affects my whole life. It affects my family's life. But I don't want to stop. And you guys are enablers. Guys, I'm addicted to batteries. We've got one on the wall behind me. We've got one in the garage. There's one in the drive. There's one in that van. Yeah, we've got a lot of batteries here, and there is a new one over there for me to reveal to you guys. So let's do that. This, people, is an enabler. Ooh. Welcome to the newest project, as if I don't already have enough open projects. This, people, is an enabler. Ooh. Think of all the batteries we can move with this. Just about fits through here and gives me the possibility to use all sorts of batteries in the rear of my property. This BYD battery will eventually end up at the back of the house on its very own framework, connected to its own inverter. But for now, we need to get it in the garage to work on it. Run! If you've not been following, I've connected 2 Tesla Model 3 batteries to a solar inverter and used them to cover my home usage and, well, even buy and sell electricity. Honestly, if I could support the grid and make a profit in some commercial battery storage, I'd have done this by now. But, well, this requires a lot of monies, lease agreements on land, and grid connections. Anyway, I'm digressing. So for now, I'm focused on doing all I can with the connection that I have, which is a 3-phase domestic supply. Why connect an EV battery, I hear you ask? Well, they are ridiculously cheap per kilowatt hour compared to DIY batteries and commercial off-the-shelf batteries. But they do come with some caveats. They are ridiculously heavy, and from a DIY point of view, they can contain 300 to 400 volts. Some as high as 800 volts. We'll get back to that challenge later on in the video. I think I have a workaround. Okay, let's get this thing turned to just one battery. So we'll stop it. We'll turn that. I'm going to take the CAN bus out for now. I'll start it back up and it'll just recognise the one battery. Okay, now we'll disconnect it in there. Okay, so we've turned it off from the inverter end, but this battery still has its contactors closed. We could, of course, just pull 12 volts, but we could be kinder to the battery and click open contactors on here. Are you sure? Yes. There we go. They made the big donk, and now we can just disconnect everything that's on here. So we've got our earth, we've got our communication, 12 volt, and our main high voltage connector under here. Let's move it all out the way, and then we can try and get this thing out of here. Okay.
Word of caution.
Always disconnect 12 volt first, and we've heard the contactors click, so we know that they are open and cannot reclose. I recognise that that was the sound of 2 clicks, so they're not welded shut and they are in fact open. Always treat it as if the battery is live, and you should probe and check that there is no voltage on the output. Now I've got this connected up to some Wagos. Yes, it's never been a kind of permanent fixture as it is. So instead of undoing these lugs, I'm just going to undo this from here. So that one out and that one out, and that is done. We've got to pull this little tab across, which will then mean we can move these, and that whole thing drops down. Okay, it's time to move the old Vito so I can get to the garage doors. The other day, it was cold and I had to use this thing early in the morning, and I had to sit in it in the cold for 10 minutes for it to de-ice itself. Honestly, my only diesel I own now, but it really felt like going backwards compared to pressing a button.
What is happening right now?
Okay. Oh, that's a nice ticky noise. Ugh. I do love this van though. I've had it for a long time. A lot of memories. Anyway. Okay, so let's get moving then, and finding out if this is the big problem of using EV batteries for home energy storage. Moving 400 kilograms safely. People, I'm not going to lie, I'm not exactly filled with confidence to move both of these batteries, stick them on that rack, and then move around 900 kilos. I've not lifted these batteries up in that orientation before, and most definitely not with that engine crane, so let's find out. I wonder, are you as nervous as I am at this stage? I mean, it could all go wrong, couldn't it? We could have the rest of the video could be the disaster that unfolded as I dropped 400 kilos of car battery. Alright, let's crack on. So the best tool that I've worked out that you can use is a 2-ton engine crane. And yes, these very much are on the limit of what these things can handle, but I've moved a few batteries now with this engine crane and it's done alright. Oops. Now, people of the internet, if you are going to move batteries, do it safely. Don't follow what I've done. Use lifting eyes and use shackles. I now have some on here, but as you'll see in the next few clips, I didn't do that. I just used the chains and I put them straight through the holes. Don't do that. That was stupid. I shouldn't have shown you that on the internet. I should have used these and shown you these. And I don't have the editing skills to edit these into the video so that you don't see that. So I'm just going to add that disclaimer and say, do it safely, don't follow me. So with both of these here, you can already tell that this Tesla pack is humongous compared to that BYD pack, and they both have the same energy in them. I think I'm gonna put some blocks under that side of the pack and then lift it up from this side. Well, that's certainly a view, isn't it? Honestly, it feels so uncomfortable. I wonder if the BYD is gonna be a bit easier. It seems a bit more compact. I'm not even sure if I'm gonna reach the full height to be able to get this thing on its side. Yeah. So it's just on the lip of that one pallet edge. I like how I put my hand out as if I'm just gonna Superman stop it, right? Well, that's good news. She moves okay. Okay, got another one to do now. While I prepare the area for the 2 batteries to sit, don't forget to like and subscribe. It makes a huge difference to the channel, and this channel's going places, and it's only because of you guys. And when I say going places, I don't mean my neighbour's driveway. You know, at this point in the day, I was super stressed out moving these batteries. It was very much on the limit of what an engine crane can manage. but I don't remember it looking this difficult to move them. Surprisingly, they move around pretty easily on this cart, and yes, my drive does have a bit of an angle. Well, you never quite know how these things are going to go, and yeah, that shelf did have quite a lot on it already. And to be honest, I do want to move it up anyway, so yeah, I'll sort this out, and we'll probably come back to this on another day. So, that's the floor tidied up, and the shelf back on. Let's work out the similarities and differences between these batteries, hey? Look how much extra room there is in the garage! Ho-ho! All the things that I can do with this space. First off, it should be incredibly obvious to you that this Tesla battery is way taller. This is about 1.4 meters wide, whereas this one is 1.2 meters wide. Bearing in mind that both of these batteries have roughly the same capacity and the same type of cells, so that's interesting. We've got a smaller package here. Lengthwise, they are about the same, but if anything, the Tesla is a little bit longer. The Tesla has water cooling or heating, useful for supercharging, not so useful for home energy storage when you're barely pushing it. Might be helpful in the middle of winter if you have super cold climate, but even in minus weather last year, that one over there was insulated and they're absolutely fine. They stayed above freezing. Okay, so the BYD down here has all of its connections in what is a little over 30 centimeters, I'd guess. It's got the high voltage power, it's got its air conditioning, so this pack is just air conditioned cooled, and the air conditioning plate, I believe, goes over the top of this. In fact, they have laid this pack out completely different than the Tesla pack. The Tesla pack has 4 big modules that snake back and forth with a pyro fuse in the middle to break the pack up if the worst case scenario happened. Whereas this has cells that go up and down, they're very thin, and they are the full width of this pack. And there are then BMS modules on the ends, which link up, and then sort of where this raised part is, there is a bus bar that comes from this end all the way down to the one side, positive or negative. And then all of the comms are handled from this port. And this is where it gets even simpler, because as far as I can see, there's no high voltage interlock in here. In fact, the cable here has the 2 pins for it in the middle, but I don't see the corresponding pins in there. So it looks like they've not bothered on this connector. There must be some sort of CAN bus high voltage interlock that connects up to the other components, such as the inverter, the air conditioning, all that sort of stuff, but we don't see it on the battery end. So they just presume that this battery connector is going to be seated, and it's going to be seated properly. And it does have backup bolts, so yeah, this shouldn't really come loose in any way, whereas the Tesla pack is using like a clampy device. Presumably, if I pulled this off now, that Tesla would just shut the contactors off, but there's a risk of an arc. Different design, that is easier to just randomly get off. This isn't going to come off unless there's a serious issue. So that makes everything a bit simpler as far as the communication through this port. Everything is done here. There's no high voltage interlock to please. And you basically are powering the 12 volts plus, the 12 volts negative, the CAN high and the CAN low, and that is it. Now, another thing I quite like about this battery is it came with a ground strap that fits on here. And that's really handy because I've had to grind through the paint on the Tesla battery in order to get a ground strap. You see, you need to ground the battery and the inverter together, and they need to be connected to the ground of Earth. Otherwise, you can end up with a potential difference of voltage on the outside because your inverter will basically kick back some voltage. Yeah, don't ask, but the simple solution is you always need to ground your case and your inverter. All of that needs to go back to the main ground of the house, which is why I fitted an earth rod, because then that gives me backup power if I want it. When we compare this to the Tesla, you've got stuff to cover here that potentially could have high voltage, your auxiliary that goes down the middle towards the front. You've got 12 volts from the penthouse that comes out, in and out, a big chunky cable. And then you have all of our communication stuff, which, if you remember right, on that we have resistors, and also we have to deal with a capacitor inside the box that's down here. Now, this needs fixing. You cannot just dangle cables. One of the humongous drawbacks with the Tesla pack, which I didn't realize when I started this project, is that the LFP packs don't seem to want to balance. What we've done so far, we've done everything we can to emulate the car. That gets rid of errors and leaves the BMS in a happy state to be able to balance. The longer that goes on without balancing, the bigger the difference gets, and this sits around 300 millivolt difference at peak. But we may have found a solution, and it's not great for home energy storage. Now, the solution to this is incredibly simple. Just open the contactors. The vehicle expects that you would charge the vehicle, put it into a full state, and then open the contactors once it's fully charged, and then that could sit for 12 hours overnight to basically just balance. And that is how the car is designed. It doesn't really balance unless the pack is at rest, which makes sense because that could sway the actual millivolt difference. So that means that balancing doesn't work great for home energy storage because you've got to then open the contactors. Now, it's possible that you have a few hours in the day when you don't actually need to connect to the battery, and for me, I could probably balance this 12 hours a day if I set up the right automations in Home Assistant. So it's not too much of a bother, but having another battery, a BYD battery, allows me to put that in its place and basically leave the Tesla in idle mode so that we can see if balancing works correctly. So I'm going to do that. I'm going to leave this battery for the next couple of weeks in contactors open mode with the battery emulator sending CAN messages back and forth, and then see if that millivolt difference comes down. Okay, so back to the differences. So you're no doubt thinking that that is a win for BYD. Well, it's not incredibly clear at the minute if BYD are balancing this as well. Now, this is kind of my own fault because I'm choosing battery packs that are LFP. Because the voltage curve is so flat on those, they really have to be at like 99, 100% in order to see that millivolt difference. Whereas the packs that contain the other lithium chemistries, those ones tend to have more of a voltage fluctuation as they charge, so it's easier for the BMS to be able to balance those in different circumstances. So yeah, we are yet to see whether this is an issue for the BYD pack. One thing that has been noted with the BYD packs is that they lose their state of charge over time. However, for me, I plan to charge this up to full and discharge it, possibly even daily. So I'm hoping that that means I'm not going to lose the scales of how charged it is. But we'll see, and we can report that back later on, can't we? Now, another potential issue with the BYD batteries that the Teslas don't have. So if the Tesla was in a crash, there's a good chance that that Tesla battery is going to show 0 volts in the battery emulator despite all the cells being at correct voltage. That tells you that the pyro fuse in the middle of the pack has blown. And that's the only time I think that you should be opening the penthouse to work on a project like this. But it does mean that you've got to deal with the high voltage and mess in the penthouse. And let's be honest, most of these come from crash damaged vehicles. If the airbag goes off, then that is what's going to happen. So use the right tools, use insulated tools, and be safe. If you don't know what you're doing, don't do it. Now, talking of safety with a EV battery like this for home energy storage, I mean, it just feels wrong, doesn't it? Like, that's not safe, is it? But it actually is pretty safe, and let me explain for a few reasons why. One, it is an automotive grade battery. What does that mean? It means it has a really hardy BMS with backup, and everything is designed for a harsh environment, both in terms of water, vibration, a whole bunch of stuff that your home energy battery probably won't actually cover. Yes, it is a bigger battery, so if there is a problem, it could be bigger. But what do the electrical standards say? Well, most DNOs don't seem to care. They're more concerned about the AC side because that is the gateway to their network. So really, what's covered is the solar inverters. They've got to meet a standard, and whatever battery you connect to it is whatever battery you connect to it. I know, it feels a bit wrong, doesn't it? In the UK, all of our standards come from this big book. It's called BS 7671. It is our wiring regulations, and in here it covers 1000 volts AC and 1500 volts DC. So yes, it does actually cover stuff like this, but what it really covers is that cables are secured, cables are the correct cables chosen for the install, and that things like fuses are suitable. Now, inside here there is a section on prosumer. And in all of this book, I find nothing that says you cannot use an EV battery for the purpose that I'm using it. Much of the electrician testing on circuits covers the AC side. Why? Well, because those are the circuits that connect into a consumer unit that most people use, and those are the ones that connect back to the grid. And then if there's anything else specific, such as the size of cable or the correct size of breaker to choose, those are just going to be inside your installation manual for your inverter. Now, I would always encourage people to get an electrician on board to cover the inverter install, maybe some solar install, capable DIYer to potentially do the EV battery side. If you can get the electrician to do the lot, then fantastic. But I have a funny feeling that with most electricians not necessarily understanding the whole connecting an EV battery to an inverter, that they're going to shy away from offering that service. Okay, so there we have it. Doesn't feel like it should be right, but it is. Doesn't mean it's always going to be like that. Of course, regulations could come in that mean you can't do this anymore, but generally, these regulations in the UK don't change unless something dramatic happens, like a big fire or somebody dying. So if we keep things safe, if we do things the proper way, we stick under the radar and we can continue to do what we're doing, hey? Let me know in the comments whether you think that this is safe or not, and please let me know of your reasons. I'm interested to hear. Right. Where was I? Oh yes, how the BYD pack stops you when airbags have gone off. The BYD pack doesn't do that. What it does is it sends a signal that basically blocks contactor closing. Presumably it opens the contactors in that situation and then just doesn't allow them to close again. But there is a workaround. Over time, people who have used these batteries for home energy storage have worked out that you can send a crash resolve signal. And fortunately, I was able to do this. So when I went to go and purchase this vehicle, it had indeed been in a crashed vehicle with airbags gone off and the contactors weren't closing. But pressing the button of clearing the crash signal, I was able to get these contactors to close without too much trouble. I just needed to power on and off the 12 volts after I pressed that crash signal. So yeah, shall we try and get this live without the little pins there and see if it will output power without any interlock being fed? Well, I've already heard them close. 421 volts. Now, quite a while ago, in preparation for this, I purchased a cable off a subscriber, and as you can see, this thing is way longer. This is actually the other end, so this end was on this end, and if I hadn't have cut the cable so long for the first battery, I probably could have made two, basically, out of one cable. Anyway, so I had to buy this off the subscriber. You know who you are. You also sent me a Scotland t-shirt, and here we are. It is on camera. So there we go. So while I terminate this into our fuse enclosure and get this connected up to the battery, you need to hear about the sponsor for this video, Incogni. Your data and my data is at risk, and Incogni will protect your data for you by contacting brokers and removing it for you. Now this is an ongoing process where they'll continually monitor and make sure your data is not in the places that you don't want it to be. Imagine doing this process yourself, contacting each one of these people by email, asking them to remove your data and then following it up. That is a lot of work, and this software does that for you. So check them out. The link is in the description. Okay, well that's great. So we can get it to output power. We've overridden the crash block. Now we just need to build it into an entire system that is usable. Now, eventually this is going to end up probably at the back of my house, but for now, to work on, I'm going to have a go at making something that mounts on the side of the battery, mounts a solar inverter on there, and mount everything on there, and we can see if that's an idea that people might copy, basically combining it all into one place with something on wheels. Now, in my view, you're going to have to kind of secure it in some way that it becomes fixed in the future. But yeah, we'll explore that in the next video. So thank you for watching, guys. It's been awesome to have actually got this in here. And yeah, don't copy my sketchiness. Do things the proper way. Use your shackles. Use your eyes. And I'll see you in the next one, eh?